Going to solve another relative motion problem. This one I've bumped it up a little bit. You can see it's a little bit weirder than we saw in grade 11. Things aren't just rectangular anymore, but the method to set it up is exactly the same. We could write out the subscript notation. Actually, we didn't do it last time, so I'm going to do it this time. We're talking about a boat through water, so the velocity of the boat relative to the ground is the velocity of the boat relative to the water, plus the velocity of the water relative to the ground.
5751, Ms. Matsubayashi, call 5517.
All right, moving on. In this one, we know both things about the boat relative to the water. It's moving 5 west. We know both things about the water relative to the ground. That's the 2.5 on the 45-degree angle. So this is one of those questions where I don't have to speculate, I don't have to guess. I can literally draw the triangle. I'm going to draw the 5 meters per second west. So pointing that way, that's the 5. Where that vector ends, I'm going to draw my second vector. I need a reference line. We're 45 degrees away from straight south, so going this way, and it's 2.5 long. A little bit messy, but that's what it looks like. Vector addition, you always connect the very, very starting point to your very, very ending point. So my solution is going to be whatever length that is, and that angle over there. Now, there's lots of ways we can solve a vector problem. Sine law, cosine law will get us there, and that might be your knee-jerk reaction. If you worked ahead and did sine law, cosine law, don't change it, you're fine. But I'm going to do it a slightly different way that some of you may not have thought about and some of you may like better. What I'm going to do is I'm going to backtrack and I'm going to think about that water with respect to the ground first. It was the one on the funny angle. If we have 2.5 on a 45-degree angle, I can go backwards and split that into 2 vectors. We call this breaking it into components. I can find its east-west component and its north-south component. This over here would be a complementary angle, so that's also 45. The side adjacent to that, so katoa, adjacent is a cosine relationship, so this side is going to be 2.5 cosine of 45. This side over here, opposite, is going to be a sine relationship, 2.5 sine 45. Sine of 45 is the same as a cosine of 45, so I'm going to get the same numbers. These end up being 1.77, give or take. By doing that backward step, I can now change my question. Well, I can change my triangle. I need to take the 5 that was pointed straight west, and where it ends...
Redfern, line 104, Ms. Redfern, line 104.
Busy day. Where the 5 ends, instead of adding 2.5 on an angle, I can add these 2 vectors. I can add the 1.77 pointed west and the 1.77 added south. So instead of that triangle with the big 135-degree angle, I've got 5 pointed west. Where that one ends, I add the next 1.77, also pointed west. I can do that pattern in my head. They add to 6.77 pointing west. Then I've got the other 1.77 pointed south. Oops, I'll switch colors again. The vector sum is the very, very start connected to the very, very end. So I'm going to call that V, and I'm going to find that angle X. It should give the exact same answer if you would have done the oblique angle way, or whatever you call that, the cosine law with the 5 and the 2.5 on the angle. This one I like better. It was a little bit more SOHCAHTOA work, but now I can finish it with just Pythagorean theorem. V squared is 6.77 squared plus 1.77 squared. You can double check within rounding. I got a nice clean number of 7 when I did that. To get the angle, the tan function this time, instead of doing sine law, is 1.77 over 6.77. Again, double check my algebra, but I'm getting 15 when I do that. If you did it the sine law, cosine law way, within rounding, we should have got the exact same answers. Putting it together, the velocity of this boat is 7 meters per second, number and unit. The direction was I measured from straight west. I rotated 15 degrees towards the south. It's not wrong to do sine law, cosine law way. I just wanted to show you an alternative. Moving forward, you can do whichever way you prefer.